Okay, now the third part in the mechanical and sound wave. Basically, starting from this part is more on sound wave. Okay, sound wave. Now, we want to learn about sound intensity. Sound intensity is actually the loudness of sound. Another term is the sound frequency. Sound frequency is the pitch or high or low of sound. What's the difference between high sound and loud sound? High sound means it's very high sound. Okay, loud sound is very loud. That's called loud sound. All right, that's called loud. So you must differentiate between a high sound and a loud sound. All right. Now, intensity. The formula for intensity is, in fact, intensity symbol is I, and the intensity formula is power over area. Okay, power over area. So you see, since intensity is about loudness of sound, so that's why it's proportional to the power of emitted, the power emitted by the sound source. So the higher the intensity, the higher the power emitted by the sound source. Okay, the loudness of sound. Okay, so intensity is actually the power emitted divided by the area distributed. Okay, since we can imagine the sound actually travel in all direction. Yeah, sound travel in all direction. The sound travel to the front, to the back, upward, downward, left, and right. The sound travel in all direction is like 3D dimension. So we can this when the source emit the sound, the sound travel in all direction. So the area basically is a sphere. We can imagine when the sound travel out, it becomes like the sphere growing bigger and bigger. That's the area of the sound distribution. Yeah, area of sound distribution is actually a sphere. Yeah, so the area of the sphere is 4 pi r square. Okay, 4 pi r square. So intensity is power emitted divided by the area of sound distributed. Okay, so intensity also equal to power over 4 pi r square. So r is actually the distance from the sound source. Distance from the sound source. So we can say the further, the higher the distance, further away from the sound source, the lower the intensity. Okay, good. Now, let's look to the formula of total energy. In the simple harmonic motion, we did learn about the formula for total energy, which is half m omega square amplitude square. Okay, amplitude square. This is amplitude, not area, not the same as the area here. This is the amplitude. And we also know that power is total energy over time. Okay? Now, look here. Intensity is proportional to the power. The higher the intensity means the louder the sound. So, the higher the power emitted. Okay? The higher the power emitted. So, intensity is proportional to the power. And since power is equal to total energy over time, so intensity also proportional to the total energy emitted. Okay? And total energy is half m omega square amplitude square. Okay? So that's why the total energy can also be represented by the amplitude square. So intensity is proportional to amplitude square. That means the higher the intensity of sound, or the higher the loudness of sound you hear, the higher amplitude of sound wave you are hearing. Okay, the higher the intensity, the louder the sound. All right, the higher the intensity, the louder the sound, the higher the amplitude. Okay, the higher the amplitude. So, okay, intensity is proportional to amplitude square. Okay, so we can make a ratio. So I1 over I2 is equal to amplitude 1 square over amplitude 2 square. When I is proportional to amplitude, so they must be at the same level. I1, A1. If I1 above, A1 must be above. When I2 below, A2 must be below. When they are proportional. Okay? So, in other words, the higher the intensity, the louder the sound, the higher the amplitude. That's why sometimes you see the radio, you increase the volume, you can see the wave become a bigger amplitude. The louder the sound, the bigger the amplitude. Understand? Good. Now, based on this formula again, intensity is inversely proportional with the area. That means the more the sound is distributed to a bigger area, bigger sphere, the lower the intensity you hear. That means if you are further away from the sound source, you can imagine the sound energy has distributed to a bigger sphere area, So the bigger the area, the lower intensity you hear because the sound is already distributed, the energy already distributed. So the intensity become lower. The bigger the area, the lower the intensity. So intensity is inversely proportional to the area. So be careful. If amplitude, it is proportional, but if area, it is inversely proportional. Same symbol, but different meaning. Yeah, this is the amplitude square. This is only area. Okay, so intensity is inversely proportional to the area. So we can make a ratio like this. Since the intensity is inversely proportional to the area, so if intensity 1 above, area 1 is below. If intensity 2 below, area 2 is above. When inversely proportional, they must be like that. One on top, one below. Okay? Now, I like this one. If it is proportional, it is at the same level. Understand that? Now, how about the distance? Same, because distance depends on the area. Yeah, the bigger the area distributed, the further away from the sound source. So intensity, because area is actually 4 pi r square. So intensity is inversely proportional to the area. So intensity also inversely proportional with the distance square. So intensity is inversely proportional with the distance square. The further away from the sound source, the lower intensity of sound you hear, or lower volume of sound you hear, softer sound you hear. Okay, because the sound energy already distributed to a bigger area. Okay, so less energy you hear. So since it is inversely proportional, so that's why when intensity is above, intensity 1 is above, R1 is below. See that? The same case at like the area. When intensity 2 is below, the distance, the R2 is above. This is what happens when inversely proportional. When proportional, they are at the same level. Okay? So I think that's all for intensity. So intensity is power over area. Power can be represented by energy, and energy can be represented by the amplitude. So that's why intensity is proportional to the amplitude square. But intensity is inversely proportional to the area, and intensity also inversely proportional to the distance square. Alright, so stay tuned for the hot part of summary. See you.